Hello students, welcome to our next lecture. In previous lecture, we had discussed about what are different kind of schedulers. We had picked there are basically three kinds of schedulers: short-term scheduler, mid-term scheduler, long-term scheduler. We have discussed that what are different functioning of those schedulers. Now, today we are going to start our new topic which is somewhat extension of the previous one, that is CPU scheduling. Now, where from where it comes, what in this topic, that is short-term scheduler. We have also discussed that short-term scheduler is also known as CPU scheduler. So, today we are going to start our discussion in context of CPU scheduling. When let's pick again the same diagram, that is our new state process once get created, then moved into the ready state. Now from ready state it will move into the running state. After that it will get terminated. Otherwise it will move into waiting state and come back again to the ready state. Now from RAM I want to send process to the CPU. Let's assume that I have only one CPU. It means I can send only one process at a time. So the thing is that out of n processes, how to make selection of one process, which we have said that is done by short-term scheduler. So once scheduler has selected, so what was the primary criteria for selection and how, according to that criteria, they have focused and generated the selection, which is also known as algorithm. So there are two major things with respect to CPU scheduling. The first one is, so what is the performance criteria, and second one is how algorithm performs the selection. Now, what is difference between these two? Because sometimes students get confused that algorithm itself have certain criteria for selection of any particular process. So this is again having selection criteria, performance itself is a criteria. So what is difference between these two? So the difference is that I have n number of algorithms and each works on different criteria. I have an algorithm. Each have its own functionality, and that is scheduling for the CPU algorithm for the CPU scheduling. Now the thing is that which algo perform better. Now how to decide this thing? That which algorithm, and every algorithm have their own way of doing things, but we require certain comparative analysis so that we can say that this algorithm is performing better than the other algorithm. So how to perform this thing? This is done by the test one, performance or scheduling criteria. On the basis of this thing, algorithm got selected, that this algorithm is most appropriate for this particular task. For example, suppose what you want, you are uh, gone for, suppose, watching certain movie. Now, you are in a queue. So definitely, if n person want to get ticket, you require certain algorithm that to whom that uh, ticket manager will give ticket first. So there are n different way to provide that thing. The first and simplest which is used, that is first come first serve. The person who will come to the queue first, he or she will get ticket first. Other one can deploy any other thing like uh, priority, that if you are relative of certain minister, you will get the first ticket. If you are from business background, you will get the second term of ticket. If you are a normal person, you will get ticket at last. So different systems can have different way of arranging those things, and each and every algorithm have their own benefit, have their own disadvantages. So which algorithm is suitable, that is decided by the performance criteria. So today what we'll do, we'll focus on performance criteria, and then we will move into the algorithm for CPU scheduling. Now, let's pick what are different criteria through which we monitor any performance. So let's try to pick that what are different criteria. So the first criteria is what we can say, how efficient way, since we are focusing on CPU, and we say that if I am able to utilize the CPU effectively, then that algorithm is much better. Now, why I am saying this? Because CPU is the fastest unit which we have in our system, and all the computations are done into the CPU. So, if CPU is idle, then it means that we are not effectively utilizing the things. Hence, our first criteria to identify that which algorithm is performing better, that could be processor utilization. That could be our first criteria. Now, what is processor utilization? Processor utilization says that how much we have utilized our processor. In general terms, I can say that average fraction of time during which the processor is busy. On an average, how much amount of time that processor is busy. Suppose I have picked that in 1 hour, on an average, 30 minutes my processor is busy and 30 minutes my processor is idle. So whatever algorithm I am using to schedule different processes, it's not that much efficient. Here, there is one star in this, that is condition applied, that suppose I have processes which want to perform for complete 1 hour, but somehow due to my algorithm, they are only able to utilize my CPU up to 30 minutes. And 30 minutes my CPU is idle. So this becomes quite important criteria once we focus on any CPU scheduling algorithm. Even all the algorithms, once we design that, these are different things through which we prove. For example, suppose you have created one algorithm and you think that this algorithm is quite new. So apart from the newness of that particular algorithm, if you want to publicize it, or if you want to say to the research community that this is my algorithm, you need to prove that why your algorithm is better. And how you will prove it? You will prove it according to the criteria, uh, or I can say performance criteria, uh, as per its field. Suppose you have created one algorithm for searching. So definitely you will prove on the criteria that my searching algorithm takes very less amount of time in searching n number of items. Hence, it is better than the previous algorithm. So you got one criteria, that is time. On the basis of that, you have proved that your algorithm is better. Similarly, in context of our CPU scheduling, because our primary concern is CPU, so we have said that processor utilization can be a primary criteria. Now, apart from that, what are other criteria? So, the second criteria which can be used, that is throughput. Now, the thing is that what is throughput? So let's take one example and we will take what is throughput. Throughput is that what I'll say, that there are, suppose 100 processes are running. So if I say that in 1 unit of time, how much amount of work has been completed, or in any 1 unit of time, how much processes got completed. This is the throughput. Suppose I have 100 processes which get completed at 1 unit of time. So that is throughput. Throughput means I am able to solve n number of problems in particular amount of time. So more problem I solve, the more effective is my system. If I have n processes and in my RAM, and I am able to solve n minus x processes at particular amount of time. So that is known as throughput. Throughput means completion of process. So how many processes you have completed per unit of time. Now, it totally depends. Suppose you have processes, 1 unit of time, each and every process wants to execute into the CPU, and you have 100 processes. And it means that 100 unit of time will be taken for completion of all processes. Now, the thing is that if I'll say that okay, in 100 unit of time, how many processes I have completed, so that is total 100. That is per unit of time, in terms of it is throughput. Now the thing is that sometimes it's not necessary that throughput will provide you the actual indication that my algorithm is better or not. Now, why I am saying this? That is, that suppose all processes which want to execute are very large, or they want to take very large amount of time, then what happens? Then definitely your throughput will get reduced. Although your CPU is completely busy, it's busy in execution of processes, but your throughput is reduced. Not even a single process is able to complete in per unit of time. So this is the disadvantage. Throughput sometimes can be very low, but why we can utilize this as a performance indicator? It also shows that our system is not able to mix multiple processes in a proper manner so that it can execute n number of or more processes it has given, or algorithm is more moving towards to the longer processes, and there is a possibility that certain new processes which are very small, they are waiting at the last, hence your throughput got reduced. So mixing is required. The throughput tells us that we can mix proper way processes. Now I'll discuss how to mix processes, what are different kind of processes in uh, I think after one or two videos. Once we will focus on algorithm, then I'll explain that what are different types of processes and how to mix those things. Currently, because we are focusing specifically on performance criteria, so let's leave. Otherwise, it will take another 30 minutes probably. So that is throughput. So throughput, once again, throughput refers to the amount of work completed in a unit of time. That is throughput. Now, let's move to the another criteria, that is turn around time. Now, what do you mean by turnaround of time? This is your homework. Uh, Try to pick what is turnaround time. In next video, we will focus on turnaround time and further few more associated time with respect to turnaround time into a next one. So that is all for today's video. Thank you.